In this video, we're going to be solving system of equation using the addition method. So let's look at an example. So for example, if we're given 4x plus 2y equal to 6 and 2x plus 3y equal to 1. So in the addition method, we look to get rid of one of the variables. So here I'll try to get rid of the y's. So the way I'll do this is by multiplying both equations. And what I'll do, I'll just interchange. So here they both have a plus sign, so I'm going to make one of the signs negative. And now distribute. So we have 12x plus 6y equal to 18. And the second equation after distribution will become minus 4x minus 6y equal to minus 2. So we've achieved our objective, which is to make the coefficients in front of the y the same amount, but opposite in sign. So adding down, the y's will cancel out, leaving 8x equal to 16. Now divide both sides by 8. And we have x is equal to 2. Now use x equal to 2 in either one of the previous equations to solve for y. So taking the first equation, we'll have 8 plus 2y equal to 6. Subtract 8 from both sides. So we have 2y equal to negative 2. Divide both sides by 2. So y equal to negative 1. So we can also write the answer as 2 comma minus 1. X value first, y value second. Okay, let's look at another example. So for example, suppose we had minus 3x minus 7y equal to 4 and 4x minus 5y equal to minus 34. Now again, we could interchange, put 7 on the outside and put y on the outside here, put 5 on the outside here. So now observe that they both have a minus sign, so I need to make one of these a minus, so make the 7 a minus. Now going ahead and distribute, and we get minus 15x minus 35y equal to 20. And then here we'd have minus 28x plus 35y. 7 times 34 is 238. So that'd be plus 238. So now we have a minus 35y and a plus 35y. They cancel out each other. Add in the x's together. That will give us minus 43x equal to 258. Now divide both sides by minus 43. So x equal to minus 6. Now that we know x equal to minus 6, substitute it in either one of our original equations. So taking the first one, so minus 3 minus 6 minus 7y is equal to 4. So plus 18 minus 7y equal to 4. So subtract 18 from both sides. So we have minus 7y equal to minus 14. And divide both sides by minus 7. So y is equal to plus 2. So our answer is minus 6, 2. Okay, now suppose we're given the system equations as decimals. So if we're given it as decimals, say example minus 0.4x plus 0.5y equal to 1.3 and 0.2x plus 0.6y equal to 0.2. So we wish to clear the decimals. So if we observe that they're all in the 10th position, so multiply by 10, that would clear the decimal for us. Same thing in the second equation. They're all in the 10th position, so multiply that by 10. So multiplying the first equation by 10 gives us minus 4x plus 5y equal to 13. And the second equation would become 2x plus 6y equal to 2. So once again, we can clear the y's out. So I have 6 here and 5 here. Again, they're both the same signs. They're both plus, so I make the 5 a negative. Okay, let's make the 5 a negative. Okay, so we have distributing the first equation. We'll have minus 24x plus 30y, 6 times 13, 6 3s are 18, so that should be 78, minus 10x minus 30y equal to minus 10. So the y's would cancel out. So here this becomes minus 34x equal to 68. So dividing both sides by minus 34, x is equal to negative 2. So now that I know that x is equal to negative 2, I'm going to use one of the equations, but without the decimals. So using that second equation that doesn't have the decimals, I'll have 2 times minus 2 plus 6y equal to 2. So here I have minus 4 plus 6y equal to 2. Add 4 to both sides. So we get 6y equal to 6. And divide both sides by 6. So we have y equal to 1. The other way that we can have a system of equations is with fractions. So let's look at an example of that. So if we're given fractions, for example, 3 over 4x plus half y equal to 2, and half x plus 1 1/4 y equal to minus a half. So so look at the first equation, put 2 over 1, and to clear this out and to get rid of all our fractions, we could just multiply by the LCD. So we're going to multiply by the LCD of 4. So multiplying each term here by 4. So the 4 and 4 will cancel out, giving us 3x. 2 will divide into 4 to give us 2y. And then 4 times 2 is 8. Now, In the second equation, 1 and 1/4 could be represented as 5 over 4. So again, our LCD. So let me rewrite this. Half x plus 5 over 4y equal to negative a half. So again, the LCD here would be 4. So distribute 4. So 4 times a half x, that will give me 2x. With the 5/4, the 4 and 4 will cancel out, leaving 5y. And then 2 into 4 will give me 2, but there's a minus sign, so minus 2. Okay, so now this is just a regular system of equations. So if I wish to get rid of the y's, I could interchange those values. So I put 2 here and 5 here and make one of them a minus. So make the 2 a minus. So now this will become, the first equation will become 15x plus 10y equal to 40. And then distributing the minus 2, that'll give me minus 4x minus 10y equal to plus 4. So plus 10y minus 10y cancels, leaving us 11x equal to 44. Divide both sides by 11. And so we have x is equal to 4. Now substitute this into one of the equations where we didn't have the fraction. So we can have 3 times 4 plus 2y is equal to 8. So 12 plus 2y equal to 8. Subtract 12 from both sides. So we get 2y equal to minus 4, and divide both sides by 2. So here we have y equal to negative 2. Okay, well, that's it for this video. Thank you for watching.